Right, in this video here we're going to be talking about the law of cosines, which is something that we can use to solve for sides or angles of a triangle that's not a right triangle. Right, remember, a right triangle is a triangle that has a 90-degree angle, and if we have that, we use what we call the SOHCAHTOA definitions of using the opposite, adjacent, hypotenuse sides of the triangle to solve for sides and angles. But those things only work when we have right triangles. And if you don't understand what I'm talking about when I say the SOHCAHTOA stuff, maybe you should go back and look at some of the videos that I did on right triangle trigonometry, where I explain all those things in a lot more detail. But again, those things only work for right triangles. So if I have a triangle that's not a right triangle, then I need to use either the law of sines or the law of cosines to solve for angles or sides. Right? And I did some videos on the law of sines. We use the law of sines when we have one of the sides and its opposite angle. So like if I know side C and I know angle C, and then I know any other thing, I know one other side or one other angle, in that case I use the law of sines in order to solve for the angles and the sides that I'm trying to solve for. If I don't have that information, I do have another method I can use, which is the law of cosines. Right? So I use the law of cosines if I know all three sides of the triangle, and I can solve for so the angles using the law of cosines. So if I know all three sides, I can use the law of cosines. I also use the law of cosines if I know two of the sides and the angle in between those sides. So like if I know side B and side C, and I know angle A, then I can use the law of cosines to solve for side A, and then I can use the law of sines to solve for other stuff. So in some problems you have to use both the law of cosines and the law of sines in order to solve for all of your angles and all of your sides. But the key thing is knowing when to use each one, right? The law of sines is when I know one of the angles and its opposite side, and then anything else. The law of cosines is either I know all three sides, or I know two sides and the angle that those two sides enclose, right? So sides B and C and angle A, that's when I use the law of cosines. Right, and the law of cosines is related to the Pythagorean Theorem. Right, if you remember, the Pythagorean Theorem is for a right triangle, right? The Pythagorean Theorem is only for a right triangle, but it says a squared plus b squared equals c squared. Well, notice here that this third part of the law of cosines, we have a squared plus b squared equals c squared. There's just some other stuff that we have to add in there, or actually subtract there, if we don't have a right triangle. Right, so there's three formulations of the law of cosines. They're all the same basic formula. It's just switching the letters A, B, and C depending on which two sides you know and which angle you know, or which angle you're trying to solve for. We use the different formulations. Right, but what it says, A squared is equal to B squared plus C squared minus 2BC times cosine of angle A. Alright, so I would use this formulation, like if I know angle A and I know side B and side C, right, if I know those two sides and their enclosed angle, well then I can use this because I know B and C, angle A, I can use that to solve for side A over there, right, so that's where I would use the law of cosines. Right, but if I know two different sides, like what if I know side A and side C and I know angle B? Well, then I use this formulation of the law of cosines. B squared is equal to a squared plus c squared minus 2ac times cosine of b. Right? And I can use that one then if I know side A and side C and angle B, I can use this law of cosines to solve for side B. Right? You can see it's the same formula, it's just switching the letters A, B, and C depending on which information we know and which one we're trying to solve for. Right? The last one here, c squared equals a squared plus b squared minus 2ab times cosine of c. Right? So that's one where we know angle C and I know sides A and B. I can use this form of the law of cosines to solve for side C. Right? So the basic pattern of the law of cosines, it's one of the sides squared, whichever one you want to start with. So if I start with c squared equals, it's the other two sides squared added together. Right? So c squared equals a squared plus b squared. If I have b squared here, on the other side I have a squared plus c squared. Right? The other two sides besides b squared and added together. If I start with a squared, it's the other two sides b and c squared and added together. Right? So whatever side I start with, the first thing I have on the other side of the equal sign is the other two sides squared and added together. And then it's always minus, right? And then always a 2. And then it's these same two sides that I had in the beginning, the b and the c. Here it's 2 times b times c. Right? Here's a and c. Here it's 2 times a times c. Right? Here it was a and b. Here it's 2 times a times b. Right? So I'm repeating the two sides that I had here in the beginning that were squared. Now I'm doing minus 2 times those same two sides, but not being squared, right? Just 2 times a times b. And then always times cosine of the angle that's opposite from the side that's way over here. So if I start with a c squared, the last thing over here is cosine of angle c. If I start with a b squared, the last thing over here is the cosine of angle b. If I start with a squared, the last thing is cosine of angle a. Right? So you can see, that they all have the same form. It's not like it's 3 completely different formulas that you have to memorize. It's really just one formula and just changing the position of the letters. Right? And if you understand that pattern of how it's put together, it's one of the sides squared equals the other two sides squared and added together, minus 2 times those same two sides from over here, times the cosine of the angle that I started with over there. Right? That's the pattern of it, no matter which one of those you use. And if you get that pattern of it, then you can use it for whichever side or whichever angle you're trying to solve for. All right? So that's our law of cosines. That's what it says. I'm going to pause this recording now and erase this and put up an example problem where we actually use the law of cosines to solve for either a side or an angle. I'm not sure what this first example is going to look like, but we'll find out real soon. All right, so the first example we're going to do, it's a word problem. I decided not to write all the words up here because that would take up like half the board just writing all the words. So I drew the picture of it that we're given, and I'm going to just read to you what the problem says. All right, so a tunnel is to be built through a mountain. All right, so here's our mountain and the tunnel connecting points A and B going through the mountain. To estimate the length of the tunnel, a surveyor makes the measurements shown in the figure here. Right, so the surveyor's here at point C, measures that he's 388 feet from point A, 212 feet from point B, and the angle between those two is 82.4 degrees. We're going to use the surveyor's data to approximate the length of the tunnel. Right, so I want to know, how long is that tunnel going to be? How much rock do I have to blast through in this mountain in order to build this tunnel? Which sounds like actually a pretty fun thing to do. All right, so surveys, if you ever seen those people surveying like out on the road with those like tripods and those little camera things like pointing around, those people use trigonometry all the time in what they do to measure distances and angles and things like that. So they do like exactly like what we're going to do in this problem. That's what surveyors do all the time. All right, so I want to find this length of this side. So we'll call this C, right, because it's the side opposite of angle C over here, right, this point down here. So I have to solve for this side of this triangle. So the first thing I have to do is, well, what method can I use? Can I use SOHCAHTOA? Can I use this stuff for a right triangle? Well, I have an 82.4 degree angle here. I don't know angles A and B, so I can't assume that either of those is going to be a right angle. And so I can't use the SOHCAHTOA definitions of the trig functions and use that to solve this because I don't have a right triangle. All right, so I can't use that. So then my other two choices are either the law of sines or the law of cosines. And if you haven't seen the videos that I've done on the law of sines, you should check those out because a lot of times we have to use the law of sines and the law of cosines together to solve some problems. For this one, I don't think we'll have to use both of them, but for some problems you do. All right, so remember the law of sines says if I know any angle and its opposite side and then anything else, I can use that to solve the triangle. All right, well, I know this angle here and I'm trying to solve for its opposite side. So if I use the law of sines, I would have to know one of these other angles and its opposite side. I know both of those sides, but I don't know angle A or B, and so I'm not going to be able to use the law of sines to figure this out. Right? There's no way I'm going to be able to figure out angles A or B in order to be able to set up the law of sines, so that's out. So I'm going to have to use the law of cosines, right? In the law of cosines, one of the situations that I mentioned a few minutes ago for the law of cosines is when I know two of the sides and I know the angle enclosed by those two sides. Right, so I know this side here, this side, and I know the angle between them. That's when I'm able to use the law of cosines, right? And since I know angle C and I'm trying to solve for side C, I'm going to use the law of cosines that starts with C squared. Right, starts with the side that I'm trying to solve for. So C squared equals, and then remember it's the other two sides squared and added together. So A squared plus B squared, and then it's always minus 2 times these two sides again. So minus 2AB times cosine of the angle that matches the side that I started with. So cosine of angle C. Right? That's my law of cosines that I'm going to have to use in order to solve for side C. Right? Now side B is this 388 feet because that's the side that's opposite angle B. Side A is this 212 feet because that's the side opposite angle A. Although it really doesn't matter which one you put in for A and B because you're just squaring them and adding them together. So you can switch the order of those, you'll get the right answer. Here you're multiplying them together. So again, if you switch the order, it's not a big deal. But technically, B is 388, A is 212. All right? So I start plugging in all the stuff that I know. which should be everything except for this lowercase c. Right? If I made my decision to use the law of cosines, if I chose correctly here, and if I identified everything correctly, I should be able to fill in everything else that's in here. Right? So c squared equals a squared, so it's going to be 212 squared plus b squared, 388 squared, minus 2 times a, 212, times b, 388, times cosine of c, angle c, which is 82.4 degrees. Wow. All right, and I had to put that times cosine down on the bottom because I ran out of room on the board here. All right, so that is my setup for this. And notice, I do have a number here for every single thing. And so now, and when you're doing law of cosine problems, generally every single time you do this, you're going to be using a calculator. I mean, yeah, you would have to, just to get this part, the cosine of 82.4 degrees, you'll have to use a calculator. And then multiplying all these big numbers, I don't know if any teachers are cruel enough to make you try to do all that stuff by hand. But in the classes I teach, I let students use calculators for stuff like this every time. Right, so it's 212 squared plus 388 squared minus 2 times 212 times 388 times cosine of 82.4. I just want to check my mode, that my calculator is in degree mode as opposed to radians. So important thing, because if your calculator is in radian mode and you type all this stuff in, you're going to get the wrong answer. All right, so there's what I type in. I just type that whole thing, 212 squared plus 388 squared minus 2 times 212 times 388 times cosine of 82.4. Right, with my calculator in degree mode, and I'm just double checking that I actually typed that all correctly. Right, and I hit enter, and I get 173,370 point something. Right, so that's my result here. Now, be careful. Right, so a lot of people say, okay, I typed all that stuff and I got my answer, so this tunnel is going to be 173,730.2367 feet long. That's not c, right? That's c squared equals that. Right, so when you're using the law of cosines to solve for a side of the triangle, just typing all that stuff in is not the end of it. That's what c squared is. To solve for c, I need to take the square root of this number. All right, so a very important thing, is a real common mistake I've seen people make in the past, is just to do all this and say, okay, there's my answer, I'm done. Right, that's c squared. Do the square root, get the actual answer for c. Right, so to do this, the square root button on my calculator is above the x squared, so it's second x squared gives me the square root. Now, instead of typing that number all over again, if you look above my my negative key down at the bottom, it says ANS. So if I hit second and then negative, it says ANS. That means answer, right? So that's going to do the square root of the answer that I got from the last thing that I typed in, right? So it's going to do the square root of that 173,000 number without me having to type 173,000 all over again, right? So the square root of that is 416.809, right? So we'll say 416.8, or let's round it to 417 feet, right? So C is equal to 417 feet. All right, so in order to build this tunnel through the mountain, we're going to have to blast through 417 feet of the mountain. All right, so that's using the law of cosines to solve for a side of the triangle. Remember, the key thing at the beginning of the problem is identifying whether to use SOHCAHTOA for a right triangle, or the law of sines, or the law of cosines. Right? Remember, if you don't have a right triangle, which we don't have here because we don't have a 90-degree angle, SOHCAHTOA is completely out. You cannot use those. Don't try to use those. Right? So don't try to say, well, this is the opposite and this one's the hypotenuse, so let me do opposite over hypotenuse and do. That doesn't work unless it's a right triangle, right? So you have to pay attention to that. And then, if I have, again, two sides and the enclosed angle, that's the situation where I want to use the law of cosines. Right? So two sides and the angle between them, I set up my law of cosines, I plug in all the numbers, and then at the very end, don't forget to do that square root to get your actual answer for C. All right, so that's an example for law of cosines. I'm going to do another video where I do a couple more examples, and I'll do an example where we use the law of cosines to actually solve for an angle instead of just a side. So make sure you check that one out because it's a slightly different type of problem. So make sure you see it so you know how to handle that when it comes up.